Smarter healthcare spending is a key focus among today's forward-thinking healthcare leaders. Finding ways to reduce the costs of delivering top-quality patient care and the amount of waste that is produced is a hallmark of more sustainable healthcare delivery. For more than 20 years, Stryker Sustainability Solutions and its predecessor companies have provided safe, effective, and environmentally sound reprocessing programs to over 2,000 hospitals and ambulatory surgery centers throughout North America and beyond. Cardiac catheterization and electrophysiology labs in many hospitals are home to some of the most critical therapeutic and surgical vascular procedures. Stryker Sustainability Solutions reprocessed vascular products include a wide range of electrophysiology and diagnostic ultrasound catheters. Additionally, some delicate vascular surgeries require the use of tissue stabilization and heart positioning devices. Reprocessing in the EP and cath lab, as well as in the operating rooms, helps keep these costly medical devices out of landfills and allows hospitals to redirect financial savings toward initiatives that may increase the quality of patient care. The electrophysiology lab is a major hospital cost center and contributes to every hospital's waste stream. Stryker has the expertise and FDA clearance to reprocess over 1,000 different catheters and cables, manufactured by every major original manufacturer. Stryker's commitment to sustainability in the EP and cath lab means that these hospital departments can become major drivers of sustainability.
Reprocessing allows us to use catheters with roughly half the cost of original manufacturer product. The catheters are safe and effective. They're manufactured and tested to the same levels of reliability as new product. This enables us to use more catheters in the same patient without the concern about increasing costs, or offer the service to more patients. At the same time, we dispose of less catheters in landfills, and we protect the environment by disposing of less medical waste.
Reprocessing of certain single-use devices has become a standard practice throughout the healthcare industry and is endorsed by the Heart Rhythm Society, as well as by infection control professionals. With over a decade of reprocessing experience, Stryker delivers clean, safe, and functional reprocessed vascular devices to its healthcare customers.
Technology is expensive. Scottsdale Healthcare has a lot of technology we offer our patients and our community. So the ability to not only save the environment by excessive waste, we can reuse one product multiple times by reprocessing it versus just tossing and bringing a new product on and tossing that in the trash. So it saves the environment, it offers the same thing to every patient, there's no difference, and it's a huge cost savings.
Let's walk through how Stryker's typical device reprocessing program works. In the EP and cath lab, catheters are wiped down, then carefully coiled and placed inside a plastic bag. Ultrasound catheters are placed inside a Stryker-provided collection tray. All catheters are placed in specialized collection containers to be picked up by a dedicated service representative. Collection methods and systems are designed to minimize rejections due to damage during collection and shipping. All incoming orders received in Stryker production facilities are first sorted according to product line. All vascular devices are separated and sent to the appropriate receiving area for initial order processing. All devices received by Stryker are accompanied by a tracking document that includes detailed customer and order information, along with a unique tracking or sales order number. Stryker's database provides full circle tracking and ensures control of every device's life cycle. After the receiving process is complete, devices are initially inspected to identify their reprocessing history. If a device has reached its maximum number of reprocessing cycles, it is immediately rejected. All rejected catheters containing platinum are sent for recycling. EP labs enrolled in Stryker's Platinum Plus program are credited for platinum content for rejected devices. Once inspection is complete and the device has been properly identified, EP catheters undergo cleaning using a pH-neutral enzymatic solution and suitable cleaning agents. The catheters are then thoroughly rinsed to remove all cleaning chemicals and dried in preparation for performance testing. Dried, clean catheters are then checked for curve performance on templates. Any catheter that does not meet stringent curve specifications is rejected. Next, the catheters are inspected under magnification for kinks, damaged handles, tags, abrasion, and contamination. Following proper collection protocol for all catheters is critical for minimizing curve failures and for yielding maximum savings. Tissue stabilization and heart positioning devices are disassembled prior to being subjected to a series of enzymatic cleaning and disinfecting steps. Foam on the suction cups and all tubing is removed and discarded. Handle components are disassembled for proper cleaning, and any debris from inner lumens is removed using special brushes. Next, devices are subjected to a number of cleaning steps, including pumping with sonication for precise amounts of time and at regulated temperatures. After a final water rinse, devices are dried by vacuum under controlled temperature and humidity levels. Prior to performance testing, devices are reassembled. Every catheter is subjected to a series of electrical and mechanical tests to assess functionality. The specifications for these tests were developed during the validation process for FDA clearance to compare their profile to that of the original device. The electrical test roadmap includes measurement and calculation of continuity and isolation using Stryker's patented electrical profile verification system. Continuity refers to the measurement of resistance of each conductive wire in the catheter. Each electrode and corresponding pin of the catheter handle is verified and compared to predefined threshold resistance values. Isolation testing detects short circuits in catheters, which is typically caused by a breakdown in electrical insulation. These short circuits are detected by measuring the electrical resistance between electrodes. For ultrasound catheters, function testing includes an assessment of ultrasound capabilities in addition to electrical safety testing. Stryker's proprietary testing system ensures that ultrasound components have not been compromised. 3D mapping capabilities are assessed by testing the tip of each catheter to confirm the integrity and accuracy of the location sensor. This sensor is responsible for transmitting the location of the catheter's tip while mapping the heart. Once catheters pass all tests, mechanical integrity is verified to check for deflection and curve performance. Catheters must meet all performance specifications to be considered for reprocessing. Any catheters that do not meet these criteria are immediately rejected and recycled. After functionality is verified, all catheters receive a final rinse with heated, reverse osmosis deionized water. Next, catheters are carefully dried and then inspected under magnification again for any remaining debris or damage. Tissue stabilizers and heart positioners are subjected to a series of final tests to ensure proper functionality and stability. After a secondary identification step, catheters are ready to be packaged. Catheters are either coiled or handled straight, placed in racetrack tubing, and then secured on an SBS board. For fixed curve catheters, a tip protector is applied to ensure curve setting. The catheters are then sealed in a mylar pouch. Scanning of the barcode generates a label on demand, which is applied to the package to ensure an error-proof labeling process. Other vascular devices have their own unique packaging. Devices that have passed all inspections and tests are packaged in environmentally controlled packaging rooms. Airflow throughout the production environment is controlled to ensure all areas remain clean. Devices are sterilized in a validated ethylene oxide chamber with biological indicators that are placed in every sterilization load. The final inspection process includes examination of the paperwork to ensure that all reprocessing steps have been performed correctly. Inspectors confirm that the package seal is secure and straight and that no foreign material is inside the package. Devices are never released until sterilization is confirmed by inspectors. After final inspection, all devices are placed into their appropriate storage boxes and sent to a device quarantine area. While devices are in quarantine, Stryker's quality control personnel examine documents to ensure reprocessing has been completed correctly. No devices are released from quarantine until the quality control team confirms that all reprocessing was performed correctly.
Well, I think it just comes down to cost savings, and that cost savings can be passed on to our patients, which is why we're all here. I guess I never really thought of it being anything but safe. It all has to go through FDA approval, and I figure if it has an FDA stamp, it's good enough for us.
I think at Scottsdale Healthcare, as the organization as a whole, we pride ourselves in serving our community. We're a big part of the community here in Scottsdale, and reprocessing just plays a big role in that. It's one way that we can ensure that the quality healthcare that we provide today is going to be here in the future.
Stryker recognizes the importance of cardiovascular medicine in every hospital's pursuit of top-quality patient care. Stryker's reprocessed vascular devices are safe and substantially equivalent to the original manufacturer devices. We hope you've enjoyed learning about reprocessing and invite you to learn more by visiting sustainability.stryker.com.